Rob Nordstrom.
I'll be covering lighting, the design and software that we used. I'll touch on the lighting control panel and then go over some cut sheets. When we started this project, we were given a narrative in the specs that told us about the location, the illumination or the minimum foot candle, the fixture type, and the controls that are used. These are just a couple of examples. Along with that, for each room, we were given exactly what room it was, what page it was. We went through the Acuity book, manually found each fixture, and used the information to find our specs and cut sheets. In this project, we used Visual by Acuity or Lithonia. First step, we would determine whether or not we're going to do interior or exterior lighting. We would import a DWG file into Visual, construct or build a 3D model. You go to each individual room, you give it its height, the work plane. It will find your IES files that you'll be using in the AutoCAD or Revit. It can place the fixtures automatically by using the auto lumen method. It'll establish the calculation zones, and then you run the software for your statistics. Now that you've built your 3D model, you can now export it back to AutoCAD, import it into Revit, place all your fixtures, and then hide the imported file after you're done placing them and you got them in the correct location. The statistics that it provides, it gives you the maximum, minimum foot candles, the maximum average. It'll lay out the fixtures for you. It can render them for you. It automatically creates your light fixture schedule and gives you other project documentation that you can follow that's very useful in your projects. Same thing with the exterior lighting. Kind of just built a room around the outside of it. Gave it a height of 30 feet to the light poles. Put our we actually didn't import this one back in because there was so little lights. There wasn't very many, so we could just throw the 14 lights on there. But it still also creates its luminaire schedule. Wrote down some manual calculations, and I'm very, very grateful that Visual does this for you, because this would be so time consuming, and just the errors, and it's just, I'm very grateful for it. And any lighting software. Most important thing for our lighting control panel, well, let me start over. Our main lighting panel, the 200 amp panel, is feeding our lighting control panel. And the main, most important is the code compliance. With the code compliance becoming mandatory nationwide, the primary driver would help you to need lighting control. The common code requirements are just space control, automatic shutoff, bi-level controlling, exterior light controlling, and display light control. These are actual pictures of the lighting control panel at Hallberg. They can also control the occupancy sensors, motion detectors, help with daylight harvesting, do the night sweeping. And here we got some fixture cut sheets. The Sarah 7, I think, is indirect lighting. I think there was 6 rows in the open office. Some recessed cans, I think we placed those in the conference room. We have LED lights for the exterior. This is for the light pole. These are along the exterior of the building. And I'll hand the specifications over to Ross.
Good morning. Specifications, basically the other half of the CAD design drawings that you written documentation that governs construction along with the drawings. Some people think that the specs will overrule the drawings, but that's kind of up in debate. In all actuality, it's supposed to work complementary to each other to clear up any discrepancies that may come along. The new version is divided up in 50 divisions and then divided down into sections. A brief history: specifications originated to assure quality control from project start to finish. Spec Intact is an automated system that utilizes standardized facility construction specifications. There's a lot of variances of basically specs, and just, again, written documentation. They eliminate costly construction changes due to omissions, discrepancies, or improper quality control. In 1965, it was conceived by NASA, converted into GE system in '76, converted into the Q1 Micro in '77, into DOS in '85, adopted by Navy '86, Army in '88, continued the Windows platform in '92, 32-bit application in '02, and then the UFGS is the Unified Facilities Guide Specifications, just more naming of it. It was formed by the DoD, and in '03 Specs Intact Editor was redesigned, migrated from SGML to XML, more tech lingo in '06. And then NASA joined the UFGS, adopted the CSI Master Format 2004, which we're all familiar with. And then '10 adopted the CSI Master Format 2010. This is kind of like the animated part right here. Right here. You can actually click your actual specification number. Help you get to your location as quick as possible. There's two basic types: your performance, standard quality achieved within the scope of your work that you want to complete. Then the second is prescriptive, specific products and vendors and even contractors that you want to utilize during your project. And those all can be brought out in your spec. Nowadays we use a combination, a hybrid of both of those two to cover all the bases. It's usually issued by the architect, by a spec writer, and he's also a qualified CCS, Certified Construction Spec Writer. And it's usually tailored to each individual project or building that you're currently working on, because they all have different specifications. As I said earlier, it assists the user in locating specific types and informations, like the divisions. You can go straight to your division that you're looking for. And then it's broken down into sections, and then the three parts: general, products, and execution. It covers details like circuit breakers, factory test or calibration, and UL requirements. Also, no work shall be done on energized equipment. Catalog numbers must be specified, shall be verified with vendors prior to ordering material, just to cover bases so no errors or discrepancies come up that you have to pay for down the road, that the design drawings won't cover. Like, you'll see your panel, but you won't know that it's the right size or right provider. This is the older version, 1995. It has 1 through 16. It seems like a lot, but it's actually smaller compared to the newer version 15. It starts with your general requirements, your site construction, concrete, masonry, metals, woods, plastics, thermal and moisture protection, all the way down to 7. Doors, windows, furnishings, and it continues on. All is mostly architectural. Our meat and potatoes is down at Division 16, electrical. Mechanical is our friend, Division 15. As I mentioned earlier, the CSI Construction Specifications Institute kind of governs the revisions and updates of the master spec. And 2004 expanded from 16 to 50. A lot of places are still using the 16 version, but the 15 is slowly working its way into the field. The 2004 edition, as I said, broken up into 50. 00 is procurement and contractor requirements. 01 is your general. 2 through 19 is your construction. 20 through 29 is our facility service subgroups, which is where we're located. Division 30 through 39 is your site and infrastructure. 40 through 49 is your process equipment. A little closer into our section, facility services. You can see right away we have 3 allocated reserved for future expansion, which I think will probably be covering more details that comes along when we're utilizing our bin with Rivet. As it gets more complicated, we need to govern and specify how we use those and what we want out of that. Division 21, your fire suppression, plumbing, 22, heat, ventilation, air conditioning, 23, 25, integrated automation. Again, our meat and potatoes, 26, we're narrowing down on what we want. 27, communications, kind of like your low voltage, 28, and is your electric safety and security. Again, kind of low voltage. We utilized 3 of these in our project. We used 26 for electrical, 27 communications, and 28 electronic safety and security. There's actually even more subsections, 25 for electrical, 3 for communications, and 4 for electronic safety. Here's a little table of contents right here, example of our spec. As I was saying, how you can pick your contractors or your vendors, the panel boards you can specify from General Electric, ITE, Square D, and Cutler Hammer. It'll just narrow down for your contractor so he knows what to choose from, so he doesn't pick these cheap generic brands that are made off-site, offshore, or Mexico, or Japan, wherever the case may be. All in all, specifications clarify. As I was saying earlier with the BIM, with Revit, it's getting more and more complex and detailed, which can help out the process and also make it, I guess, can be a headache sometimes when you start getting all these details that need to be specified, and the spec needs to keep up with that. That's why we have those allocated room for expansion specs. That is it. Thank you for your time.
Did everybody use spec and tax, or is that something you
No,
chose to use?
we didn't actually use that software itself, because that's the animated part of it. That was more research of the origin and what
Okay, so you
utilizes.
didn't actually work in spec and tax?
No, we didn't use that software itself, because that's like the automated part. And you
I
had to
just
get-
did that recently at a Navy job, that's a huge head.
Yeah,
I was just curious.
you had to get like a login and a username and get all registered to your website. But
While you guys are there, I didn't see any slide on the layout of the circuit thing that you did. But I want you to assure that you did layout of the
Yes.
system and circuit. It would be nice if you just showed some layout of the circuit to the industry, how we circuit the ground, especially for life, so.